Greetings to all the viewers. The session is going to deal with external treatment of water softening by ion exchange process. This is the part of water and its treatment chapter from engineering chemistry. The topic what we are discussing taken from the textbook of engineering chemistry authored by Dr. Kavitha Kuttireddy Kota. Earlier also series of sessions we already recorded. All are available at the channel Dr. Kavitha Chemistry Academy. Earlier it will be World of Competitive Chemistry. You can find conceptual based, competitive based, research based, and government examination based, entrance examination based chemistry at the Dr. Kavitha Chemistry Academy channel. External treatment of water is nothing but before feeding into the boiler, if water is supposed to be treated and softened, that is called external treatment of water. Softening of water by ion exchange process. Ion exchange process known as demineralization. Demineralization is nothing but whatever dissolved minerals present in the water are removed by this demineralization process, and that is taken with the ion exchange. Replacement of all dissolved cations with H plus, all dissolved anions with OH minus taken. Hence, you can designate it as a ion exchange process, right? As we already aware, hardness induced by the calcium and magnesium ions in the form of chlorides, sulfates, bicarbonates, nitrates, etc. So here cations like calcium and magnesium replaced with H plus, and all the anions replaced with OH minus ions by ion exchange process. Ion exchange resins are insoluble, cross-linked in nature, and organic polymers with the polystyrene moieties are located over there, and they are microporous in nature, which are very specific for cations with H plus, anions with OH minus ions. And here certain functional groups are located upon these polymeric chains so that they used to exchange the ions. Resins with the acidic functional groups are capable of exchanging all cations with H plus, and resins with basic functional groups are capable to exchange anions with OH minus ions. This is the way softening of water by the ion exchange process taking place. This is the styrene moiety. These molecules are repeated several times. Resins are cation exchanging resins and anion exchanging resins are present. So here the styrene which were taken are repeated several times, just like this. This is the styrene skeleton. You can notice the sulfonic acid functionality. And here also sulfonic acid is located. This kind of a cross-linked polymeric chain is located, and the free sulfonic acid moieties are susceptible to release H plus ions into the water in order to release H plus ions and exchange with that calcium and magnesium, so that cation exchanging resin example it will be. Polystyrene copolymer, strong acidic sulfonic acid located over the cation exchanging terminals, and it is sulfonated kind of resin. Cation exchange resins are styrene and divinyl benzene copolymers, which are sulfonation carboxylation taken. Though the kind of carboxylic acid or sulfonic acid present on that, the ultimate use will be release of H plus ions into the water, as it is the cation exchanging resin. Which are responsible for exchanging their hydrogen ions with the cations which dissolved in the water, so that softening exchange of cations are possible here. So simply the chemical representation is provided for cation exchange process. So this is the resin you are taking with. The resin is a complicated one, need not to write the entire skeleton always. That's the reason why simply you indicated with R. R stands for resin. And resin having tendency, cation resin having tendency to release H plus into the water specifically. That's the reason why hydrogen is manifested over its terminal. And here the salt, if you are having calcium bicarbonate in the water as the dissolved compound, so it able to replace the cation calcium with the H plus, so that here resin is retained with the calcium and hydrogen released into the bicarbonate, and ultimately carbonic acid will be evolved. And the resin also bind up with the magnesium bicarbonate, giving rise to magnesium binding resin and the free carbonic acid released. The same manner, if calcium chloride, magnesium chloride treated with this resin, there is a probability for that resin with the calcium and magnesium complexation, and here is the hydrochloric acid is the output. So in case of that resin is cationic resin is treated with the ions like magnesium sulfates and calcium sulfates. If such kind of salts are added with these, so they're able to retain the metal, and the free release of sulfuric acid is possible into the water. Ultimately, cations are retained by the resins if you absorb, and there is the free release of acids into the water is possible. Carbonic acid in case of bicarbonates, hydrochloric acid in case of chlorides, sulfuric acid in case of sulfate kind of anions if present in the water. This is the way cation exchange completed. Now water is becoming acidic because acids released into the water. Now it turned to enter into an ionic chamber where you can observe again the styrene skeleton which are cross-linked. There is a provision for the free release of hydroxide ions whichever present and the quaternary nitronium cation. These quaternary nitronium hydroxides are having more susceptibility to release these hydroxides into the water, so that anion exchange is taken conveniently, and this kind of anionic resin suitable for all the anion absorption. Polystyrene copolymer where the quaternary ammonium hydroxide at the base terminals are absorbed over there. And anion exchange resins are phenol formaldehyde, amine formaldehyde copolymers, which contains the amino basic functional groups over there, and hydroxide is released into the water and the anions taken by this resin. Again, chemical representation is provided whenever the resin is indicated. This is here R stands for anionic resin with the free hydroxyl on its terminal, and that having tendency to accept this carbonic acid. Whenever carbonic acid accepted by this resin, there is a formation of resin bicarbonate, and this having tendency to release OH minus, so that hydrogen will be bonded with that, when ultimately water is generated by this anion exchange process. So ROH again treated with hydrochloric acid, there is the formation of RCl, resin chloride will be generated, and there is again release of water taken. And resin hydroxide treated with sulfuric acid, formation of resin sulfate and water formation is possible. This is the way cation and anion exchange process taken place in the two different chambers. Ultimately, water is freely released into the water without any ions. Hence, the process is said to be demineralization. In the ion exchange process, hard water is allowed to pass through cation exchange resins to remove the calcium and magnesium cations. Equivalent amount of hydrogen positive charged ions will be released. Whereas anion exchange resin able to remove the bicarbonates, chlorides, and sulfates from the water, and the equivalent amount of hydroxide released into the water. Ultimately, you can achieve the formation of water as a demineralization process. These released ions in the water, respective cations and anion exchanging columns, get combined to produce the water as the final product. The water coming out from the exchanger, free from all the anions and cations, zero hardness is achieved by this ion exchange process. Here is the clear description regarding that manifestation of its diagram where the exchange of ions taking place. Schematic representation is provided. Let me introduce water from this inlet. Hard water is supposed to enter into this chamber where you are absorbing cationic resin directly. Raw water taken which is fed into this cationic resin. Cationic resin is totally made up of polystyrene linkages upon the terminal active sulfonic acid or carboxylic acid located over there, and at the bottom you can notice the gravel layer for the absorption of any kind of precipitated or suspended impurities over there. And here the regenerating chamber is also located. Acid solution is there for the regeneration. And whenever the water entered into acid cationic resin, so all the cations retained and acidified water now supposed to enter into this pump. And here there is a provision to enter in the next chamber, which is anion exchanging chamber. Anionic changing chamber is made up of again polystyrene. At their terminal, we can notice the quaternary ammonium hydroxides, free release of hydroxide taken into the water, and the retention of all the anions dissolved form taken by these resins, and the gravel layer used to absorb all the kind of solid impurities still remains within the water. So the turbidity free water and ion free water is coming from this outlet. So the softened water taken collected from this outlet. There is another connecting chamber with respect to this anionic resin. There is an alkaline solution which is used for the process of regeneration. Right, so this is the entire process how the ion exchange process, purification taken, and the softening process is possible. All the steps are manifested in the single diagram. And here is the resin. You can clearly observe this resin is indicated as a cationic resin, where you can notice the free H plus ions over its surface, which are susceptible to release into the water. Whenever this resin is added to the water, which is supposed to be purified, so that resin can acquire all the cations like calcium and magnesium, and free release of H plus into the water taken by the exchange of cations. In the similar manner, anion exchange resin having a susceptibility of hydroxide ions on its open surface, and they are easily released into the water. Whenever this resin is in contact with the water, so that anions retained by these resin molecules and resin polymers and free hydroxides released into the water. So resin retaining chloride, sulfates, bicarbonates in this manner. This is the way exchange of anions taken in this anion exchanging chamber. After the entire process of exchange of ions, resin is supersaturated, where the entire its sieves and pores got occupied by the cations and anions. At the time, further free release of H plus may not be possible, being they are totally disappeared from the surface. Rather, they are occupied by the calcium and magnesium ions. Now it's time to regenerate that one, being it is exhausted. Cation exchanger loses capacity to produce H plus, and anion losing the exchange of OH minus totally, its capacity totally lost. At that condition, you can say the resins are totally exhausted. Resins are exhausted. The exhausted cation exchanger resin passed it through the dilute hydrochloric acid or sulfuric acid. When you are taking the resin retained by the calcium and magnesium ions, I am taking hydrochloric acid as a regenerating agent, so that the resin now retains its hydrogen atoms over its surface, and the calcium is discarded. As a byproduct, calcium chloride is evolved. If sulfuric acid used as a regenerating agent, that resin magnesium now treated with this sulfuric acid, there is a resin retaining these hydrogens, and magnesium sulfate will be released into the water. At the same time, exhausted anionic resin also super treated with sodium hydroxide alkaline solution, where the anions whichever retained by the resin now replaced with the hydroxide, so that regeneration of resins are possible. In case of sulfate as an anion, so the sodium sulfate byproduct is originated, and resin accompanied by the chloride. Sodium chloride is the byproduct. If bicarbonate is there with the resin, there is a sodium bicarbonate as a discard. This is the way entire process exchange of ions taken, and moreover regeneration is also carried in order to repeat the process with the same resin for several times. So using this ion exchange process, we have so many advantages. The process can be used soften highly acidified and alkaline water as well. Extreme conditions can also properly treated by means of this ion exchange process. Water softened by this ion exchange process is extremely soft, and low hardness is accompanied. Up to 2 ppm only there is a provision, so that it is more accurate method for the softening of water, which can be utilized for the industrial steam generation process further. It's a very good and treatment process, especially in the high pressure boiler conditions. So though we are generating steam in the high or bulk scale, at that condition, industrial grade steam can be generated by using this ion exchange process of the water, being it is more efficient method. This method is very rapid and simple to operate. That's the reason why this ionic change is most frequently adopted for the softening of water. And there are certain limitations also accompanied by ionic change process, but they are negligible in front of that kind of advantages with the method. The equipment is somewhat costly. That's the reason why establishment is somewhat expensive method. And if the turbidity is there, the sieves, whichever pores present on the surface of exchanging resin, they totally sealed, so that turbidity must not be present within the water. Then only we can conveniently operate this ionic change process. Otherwise, total resin got blocked by these turbid matter on their sieve, so that exchange process totally blocked. Resins are expensive and are replaced with we need to replace for every 6 months, being it is somewhat expensive, so that it is a laborious process and expensive process as well for the exchange of resins. Apart from that, most of the advantages we can avail by means of this ionic change, and moreover, it is the most commonly applied method for water softening, so that external treatment of water most conveniently carried by this ionic change process. Hopefully, you understood the concept very well, and the kind of things are very important for engineering chemistry as well. You can watch the channel regularly, and the content what we are introducing, you can focus on that and share with your friends as well, and like, subscribe, share the channel, and we will get new content definitely every day. Thank you very much. Signing off, Dr. Kavitha Kottireddy Kota.